Welcome. Today, we are looking at motion. This is topic 3 in your SS1 physics series. This topic covers linear motion, projectile motion, and circular motion. This is a guaranteed essay question in your examinations. Pay close attention. Let us begin. First, let me explain what motion is. Motion is the change in position of an object with time. It is a fundamental concept in physics. An object is in motion if its position changes relative to a reference point. Motion can be described in terms of distance, displacement, speed, velocity, and acceleration. Understanding motion is essential for understanding mechanics. It is essential for understanding many physical phenomena. Motion is classified into different types. These include linear motion, projectile motion, and circular motion. We will examine each type in detail. Let us start with linear motion. Now let me explain linear motion. Linear motion is motion in a straight line. It is the simplest type of motion. It can be uniform or non-uniform. Uniform linear motion is motion at constant speed. The object covers equal distances in equal times. Non-uniform linear motion is motion at changing speed. The object covers unequal distances in equal times. Linear motion is described by several quantities. Distance is the total length covered. It is a scalar quantity. Displacement is the change in position. It is a vector quantity. Speed is the rate of change of distance. It is a scalar quantity. Velocity is the rate of change of displacement. It is a vector quantity. Acceleration is the rate of change of velocity. It is a vector quantity. These quantities are essential for describing motion. Distance and speed are scalars because they do not have direction. Displacement, velocity, and acceleration are vectors because they have direction. Understanding these quantities is essential for solving motion problems. Now let me explain the difference between distance and displacement. Distance is the total path length covered by an object. It does not depend on direction. Displacement is the straight line distance from the starting point to the ending point. It depends on direction. For example, if you walk 5 meters east and then 5 meters west, the distance is 10 meters. The displacement is 0 meters because you return to the starting point. Distance is always positive. Displacement can be positive, negative, or 0. Distance is a scalar. Displacement is a vector. Understanding this difference is essential for solving motion problems. Many students confuse distance and displacement. You must remember that displacement considers direction. Now, let me explain the difference between speed and velocity. Speed is the rate of change of distance. It is a scalar quantity. Velocity is the rate of change of displacement. It is a vector quantity. Speed tells us how fast an object is moving. Velocity tells us how fast and in what direction. For example, a car moving at 60 kilometers per hour has a speed of 60 kilometers per hour. If it is moving north, its velocity is 60 kilometers per hour north. If the car turns, its velocity changes even if the speed remains constant. This is because velocity includes direction. Understanding speed and velocity is essential for describing motion. Now let me explain acceleration. Acceleration is the rate of change of velocity. It is a vector quantity. Acceleration occurs when an object speeds up, slows down, or changes direction. The formula for acceleration is A equals V minus U over T. A is acceleration. V is final velocity. U is initial velocity. T is time. Acceleration is measured in meters per second squared. Positive acceleration means speeding up. Negative acceleration means slowing down. This is also called deceleration. Acceleration is essential for describing changes in motion. For example, when a car starts from rest, it accelerates. When a car brakes, it decelerates. Now let me explain the equations of linear motion. The equations of linear motion are used to solve problems. They are also called the SUVAT equations. SUVAT stands for displacement, initial velocity, final velocity, acceleration, and time. There are four main equations. The first equation is v equals u plus at. V is final velocity. U is initial velocity. A is acceleration. T is time. The second equation is S equals ut plus half at squared. S is displacement. The third equation is v squared equals u squared plus 2as. The fourth equation is S equals half times u plus v times t. These equations apply to uniform acceleration. They are essential for solving motion problems. You must memorize these equations. You must know when to use each equation. For example, if you know u, a, and t, use the first equation to find v. If you know u, a, and s, use the third equation to find v. Now let me explain how to use the equations of motion. To solve a problem using the equations of motion, follow these steps. First, identify the known quantities. Second, identify the unknown quantity. Third, choose the appropriate equation. Fourth, substitute the values and solve. Fifth, check your answer. For example, a car starts from rest and accelerates at 2 meters per second squared for 5 seconds. What is its final velocity? U equals 0. A equals 2. T equals 5. Use v equals u plus at. V equals 0 plus 2 times 5. V equals 10 meters per second. The final velocity is 10 meters per second. Another example. A car traveling at 20 meters per second brakes and stops in 4 seconds. What is its acceleration? U equals 20. V equals 0. T equals 4. Use V equals U plus at. 0 equals 20 plus 4. A equals negative 5 meters per second squared. The acceleration is negative 5 meters per second squared. This means deceleration. Now, let me explain projectile motion. Projectile motion is motion in 2 dimensions. It is motion under the influence of gravity. A projectile is an object thrown into the air. It moves in a curved path. This path is called a trajectory. The trajectory is a parabola. Projectile motion has 2 components, the horizontal component and the vertical component. The horizontal component has constant velocity. There is no acceleration in the horizontal direction. The vertical component has constant acceleration. The acceleration is due to gravity. It is 9.8 meters per second squared downward. The 2 components are independent. They can be analyzed separately. This is the key to understanding projectile motion. The horizontal motion does not affect the vertical motion. The vertical motion does not affect the horizontal motion. Now let me explain the equations of projectile motion. The equations of projectile motion are derived from the Suvat equations. The horizontal displacement is x equals u times cosine of theta times t. U is the initial speed. Theta is the angle of projection. T is time. The vertical displacement is y equals u times sine of theta times t minus half gt squared. G is the acceleration due to gravity. The time of flight is t equals 2u sine theta over g. This is the total time the projectile is in the air. The maximum height is h equals u squared sine squared theta over 2g. This is the highest point reached. The range is r equals u squared sine 2 theta over g. This is the horizontal distance covered. These equations are essential for solving projectile problems. They are frequently tested in examinations. Now, let me explain the factors affecting projectile motion. Several factors affect projectile motion. The first factor is the initial speed. A higher initial speed increases the range and maximum height. The second factor is the angle of projection. The angle affects the range. The maximum range is achieved at 45 degrees. The third factor is the acceleration due to gravity. Gravity affects the time of flight and maximum height. On the moon, gravity is less. The range would be greater. The fourth factor is air resistance. Air resistance opposes motion. It reduces the range and maximum height. In many problems, air resistance is neglected. Understanding these factors is essential for solving projectile problems. Now, let me explain circular motion. Circular motion is motion in a circle. It is motion at a constant distance from a fixed point. Circular motion can be uniform or non-uniform. Uniform circular motion is motion at constant speed. The speed is constant, but the direction changes. This means the velocity changes. There is acceleration. This acceleration is called centripetal acceleration. Centripetal acceleration is directed towards the center of the circle. It is given by A equals v squared over r. V is the speed. R is the radius. Centripetal force is the force that causes centripetal acceleration. It is given by F equals mv squared over r. M is the mass. Centripetal force is directed towards the center. Without centripetal force, the object would move in a straight line. Now let me explain the difference between centripetal and centrifugal force. Centripetal force is the real force. It is directed towards the center. It is required for circular motion. Centrifugal force is a fictitious force. It is not a real force. It is an apparent force. It is directed away from the center. It is felt by an observer in a rotating frame. For example, when a car turns, the passengers feel pushed outward. This is centrifugal force. However, the real force is centripetal force. The car provides centripetal force through friction. Understanding this difference is essential for understanding circular motion. Now let me explain angular motion. Angular motion is motion in a circle described by angles. Angular displacement is the angle through which an object moves. It is measured in radians. Angular velocity is the rate of change of angular displacement. It is measured in radians per second. Angular acceleration is the rate of change of angular velocity. It is measured in radians per second squared. The relationship between linear and angular quantities is important. The linear speed is v equals omega r. Omega is angular velocity. The linear acceleration is a equals alpha r. Alpha is angular acceleration. Angular motion is essential for understanding rotational dynamics. It is used in many applications. Examples include wheels, gears, and turbines. Now, let me explain the relationship between linear and circular motion. Linear and circular motion are related. In uniform circular motion, the speed is constant. The direction changes continuously. This means the velocity changes. The acceleration is directed towards the center. This is centripetal acceleration. The period is the time for one complete revolution. It is given by t equals 2 pi r over v. The frequency is the number of revolutions per second. It is given by F equals 1 over t. The angular velocity is omega equals 2 pi f. These relationships are essential for solving circular motion problems. You must understand the relationships between linear and angular quantities. Now, let me explain the applications of motion. Motion has many applications. Linear motion is used in transportation. It is used in cars, trains, and airplanes. Projectile motion is used in sports. It is used in throwing and jumping. It is used in ballistics. Circular motion is used in machinery. It is used in wheels, gears, and turbines. It is used in satellites. Understanding motion is essential for engineering. It is essential for many technologies. Motion is a fundamental concept in physics. It is essential for understanding the physical world. Now let me give you sample exam questions. Define motion. Motion is the change in position of an object with time. State the equations of linear motion. U equals U plus at. S equals ut plus half at squared. V squared equals u squared plus 2 as S equals half times u plus v times t. Explain projectile motion. Projectile motion is motion under gravity in 2 dimensions. It has horizontal and vertical components. Define centripetal force. Centripetal force is the force directed towards the center of a circle that keeps an object in circular motion. Explain the difference between speed and velocity. Speed is a scalar. Velocity is a vector. State the equations for time of flight and range in projectile motion. Time of flight is t equals 2u sine theta over g. Range is r equals u squared sine 2 theta over g. Let me summarize. Motion is the change in position of an object with time. Linear motion is motion in a straight line. The equations of linear motion are v equals u plus at, s equals ut plus half at squared. V squared equals u squared plus 2 as s equals half times u plus v times t. Projectile motion is motion under gravity in 2 dimensions. The trajectory is a parabola. Circular motion is motion in a circle. Centripetal force is directed towards the center. Angular quantities describe circular motion. Understanding motion is essential for physics. Practice these concepts. When you have them down, move to topic 4.